Hello guys, welcome back to Math Zone African Motives. We are still on our revisions and this is for our June examination. So I'm going to consider a typical mid-year controlled test which was written in June 2025. All right, so we were given this, the mark allocation 60 marks and the time allocation was what? 75 minutes for what we are given. So make sure you understand that for the mid-year controlled test, you are actually working with the topics that you covered since term one, from your term one. So that's your term one up to what? Up to term two. Meaning to say, from term one, considering the whole numbers, the integers, common fractions, decimal fractions, exponents, numeric and geometric patterns, functions and relationships, algebraic expressions, you must go through these, all right, before you sit for your mid-year controlled test. You must understand all these basics, all right? So let us see what we have here. This is our instructions and information. So that's, make sure you go through. We are given that this controlled test consists of 5 questions. Answer all the questions that you're given, all right? And if necessary, all answers should be rounded off to what? 2 decimal places unless stated otherwise. All right, so that is what you're given. So you can download the question paper if you check the comment section. All right, if you go through the comment section, you can see, all right, there is a link where you can actually download the question paper so that you can properly see the questions that we are given. So I'm not going to dwell much. Let us consider question number 1. On 1, we are given here, various options are provided as answers to the following questions, and choose the answer and write only the letter A to D next to the question number. And we are given here, these are the questions that we are given on 1.1. What is the additive and multiplicative inverse of 1 over 3? All right, so let us start with the additive inverse. All right, so we do understand for the additive inverse, if you are to consider this, the product of a number, if you are to add a number to the negative of that same number, you are supposed to obtain what? You're supposed to obtain a 0. That's additive. If you add a negative to the given number, you must obtain a 0. So in our case, the number is given as 1 over 3. So it must be added to what? To its negative, so that we obtain what? So that we can obtain a 0. That is the case of our additive. It must be added to its negative. So the additive must be what? The additive inverse must be minus 1 over 3, the negative part. And if we are to consider the multiplicative inverse, all right, for the multiplicative inverse, we do understand that when a number is multiplied to its reciprocal or its inverse, the reciprocal of that number that we are given in the first place, we are going to obtain what? We are going to obtain a 1. So in our case, we are already given our number as 1 over 3. So it must be multiplied to 1 over that number, which is what? Which is 1 over 3. 1 over that, in order for us to obtain what? A 1. So this is our multiplicative inverse. 1 over this, 1 over 1 over 3 is equal to what? Is equal to 3. It simply means inverse. That is 3 over what? 3 over 1, and that's a 3. Or you can use your calculator in this case, 1 over what? Put a bracket, then you write 1 over what? 1 over 3. So this is going to give us what? A 3. That is the multiplicative inverse here. It represents what? A 3. So 1 over 3 times a 3 is supposed to give us a 1. So this is what we need. So that's the multiplicative inverse is what? Is 3. So in this order, the additive is minus what? Minus a third. Multiplicative is 3. So where do we have this condition? Minus a third and a 3. That's on what? On B. So this is our additive inverse. This is our multiplicative inverse in that order that we're given from the question above, right? So that was it. That was it. Let us consider the next part where we are given which fraction is equivalent to what? 40%. All right, as a percentage. All right, so how do we get rid of the percentage? That is the question here. How do you get rid of what? The percentage. To get rid of the percentage or to remove a percentage, we simply divide by what? By 100. So which fraction is equivalent to that? All right, 40 over 100. In a simplest form, all right, if we are to write this in simplest form, 40 over 100 like this, it is going to give us what? 2 over 5 in simplest form. So as you can see, we have that here, 2 over what? 2 over 5. We have it on what? On C. So the first one is 4 over 100. This is wrong. This is wrong. This is wrong. All right. So that's 2 over 5 in the simplest form, 40 over 100. So that was it. All right. What is the exponent of the term with the greatest or with the largest coefficient in the expression? All right, so that is our 1.3. We are given there. What is the exponent of the term with the largest coefficient? So when there is a coefficient, we must have a variable like the coefficient of x, the coefficient of x squared, the coefficient of x cubed, something like that. We must have a variable that is what? Affecting. So in our case, where we have got the variables, it is on what? Minus 4x cubed. And this minus 3x squared, and on this x. This is where we have got what? The variables, where we have got x. So where do we have the largest coefficient? All right, where do we have what? The largest coefficient from these variables. Remember, the coefficient of x cubed is what? Minus 4. The coefficient of x squared is what? Minus 3. The coefficient of x is what? Minus 1. So we are talking about the largest coefficient. So which one is the largest? Minus 4, minus 3, and minus 1. The largest is what? Negative 1. That is where we have got the largest coefficient comparing these numbers. 7 is a constant, guys. We do not have a variable. It's just a constant. Not a coefficient, but a constant. So this is the largest coefficient from where we have got what? The variables, minus 1. But our question is not about the largest coefficient, no. It's about the exponent of the term, which, with what? With the largest coefficient, the exponent of the term with the largest coefficient. So we saw that the largest coefficient is negative 1, which is taken what? From minus what? From minus 1x, from minus x, minus 1x. So what is the exponent of the term? The term here, what is the exponent of x? X is raised to the exponent of what? Of 1. This is our question here, that what is the exponent of the term with the largest coefficient? The largest coefficient is what? Negative 1. Compared to this, we saw that it's negative 1. But what is the exponent of the term. So the exponent is what? Is 1. So that is 1 is on what? On B. So the best answer on 1.3 was going to be B. That is the condition. So if let's say it was minus x cubed, and this is where we've got the largest coefficient, the exponent is what? The exponent will be 3. So they are referring to the exponent of the term where we've got what? The largest coefficient of the in the given what? In that given expression. So that was the condition of 1.3. Let us consider 1.4. Simplify these 3 to the exponent of 2 times 3 to the exponent of 4. Same basis under multiplication, simply add what? The exponents. 3 to the exponent of 2 plus 4. That's 3 to the exponent of what? Of 6. 2 plus 4, that's a 6. And 3 to the exponent of 6, we have it on what? On D. So that was the best answer. Simply using the laws of exponents, we can add those exponents under a multiplication of the same base. We are talking about the same base of what? The base of 3. All right, let us move on to 1.5. The table here represents the relationship between x and y. What is the value of a? All right, from this. So if we check, these are the output values. All right, we have got y as what? Output values. So the output values, they actually form a sequence or a pattern. All right, we have got a 3 followed by a 5 followed by what? By a followed by what? By a 12, as we have these outputs. They are taken in the same order, is that 2, 3, 4, 5. As you can see here, we are maintaining, this is consecutive, 2, 3, 4, 5. Yeah, we never skipped a value in this case, all right? So these numbers that you're given are following each other. So meaning to say that these terms are like this. Is there anything that we can do to find the value of a from here? If we are given here, let's say we use the concept to say there is a constant difference of 2, we will be mistaken because here we've got an unknown value. We do not know what is the common or the constant difference. Here also we've got an unknown value, which is a, so we do not know the constant difference. If let's say we were having another number here, we're going to verify with the first 2 to see if there is what? A constant difference of 2 throughout. So in this case, this is going to limit us. So what can we do? We can work with the answers. Since they gave us these values, let us verify which part is going to give us a pattern, a complete pattern when we substitute that for a. All right, when a is 6, let us see what is going to happen here when a is 6. We have got, let's consider the difference. As you can see, guys, the ratio is not going to work. So the difference between these terms, all right, 5 minus 3, that's a 2. We subtract here 6 minus 5, that's a 1. We subtract here 12 minus 6, that's a 6. So you can see, guys, this does not even make sense. Does not even make sense at all. We cannot say there's a pattern. No. 2, 1, 6. There's nothing like that. All right, let's substitute this one as a 7. We put a 7 here. We do the same. 5 minus 3, that's a 2. 7 minus 5, that's a 2. Then 12 minus 7, it is going to give us something else. It's going to give us a 5, which is not what we need. This is a 2. This is a 2. Here there's a 5. So it means this is not a pattern. This is not a sequence at all. It is not forming what we want. What about when it is 8? All right, let's see. 5 minus 3, that's a 2. 8 minus 5, that's a 3. 12 minus 8, that's a 4. All right, 2, 3, 4. We can see this can be a sequence because we can say there's a difference of 1 on these differences that we have. So we see if there's a difference of 1, if this is 2, the next one is 3. The other one is 4. We know that the following is going to be what? 5, 6, 7, and so on. So it's a pattern that is being formed that we can even add to say the next one we know that is going to be 12 plus 7, 12 plus 5, which is 17, 17 plus 6, another one like that. So we can see from the differences that we have formulated here that this is actually a pattern that is being formed. So if it is a pattern, it means it represents a function. It's a function which can be created. So A can be equal to what? A can be equal to 8. When A is equal to 8, it gives us a sequence or a pattern from that, all right, which makes it to be true. The first two, they were not giving us any pattern. We're trying to formulate what is there's a 2, there's a 2, there's a 5. This does not make sense. So how do you know about the one that is going to follow? Is it going to be a 5? Is it going to be a 6 or a 7? You see? All right. Let's not end it there. Let's try a 9 and see if this was going to give us a pattern. 3, 5 minus 3, that's a 2. 9 minus 5, that's a 4. And 12 minus 9, that's a 3. 2, 4, now is a 3. This does not make sense. You started with the 2, you go to 4, now you go back to 3. So what will be the next value here? We do not even know how this pattern or sequence is going. So this is not a proper pattern to what we know when A is equal to what? When A is equal to 9, it's not giving us what? The proper pattern. So it's about giving us what? The proper pattern for the value of A that we are going to substitute from the given values. That's another way that you could have worked with. Since we are given what? Since you are limited here, you cannot formulate from this one, guys, to say from here there's a difference of 2. So what about this one? We cannot formulate from there unless you've got any other way. You can do that, but the best was just to substitute the values that you're already given like that. Then you see which one gives you a pattern, right? A sequence of what? Of number, a sequence being formulated from there, right? So that is playing around with your questions, all right? Let us move on to question number 2. On 2.1, calculate the HCF of these and these through prime factorization, and that is just for 2 marks. I is expressing 1,800 as a product of for 2 marks. We can just use our calculator for that. All right. So that is 2.1. 1,800 is equal to, all right, from our calculator expressing this as a product of its prime factors, that is 1,800 is equal to. Then you press shift, this shift, then fact, this one, this fact, this these dots, this one, the dot and that thing. All right, so that is the concept. So it's shift, then you press that. So this is what you have, 2 to the exponent of this and that. All right, so for 2 marks, guys, for 2 marks, just use your calculator there. All right, then 375 is equal to, right? So 375 is equal to, then you do the same shift, you press fact, 3 times what? 5 to the exponent of 3. 3 times 5 to the exponent of 3. All right, 300, you do the same thing. 300, the same thing. 300 is equal to, then shift, you press fact. So that's 2 to the exponent of 2 times 3 times 5 to the exponent of 2. All right. So this is what you are going to simply have from the given information. So what is the highest common factor? We do understand that the highest common factor when you are given in this exponential form, one, you must consider where you have got what? The smallest powers. All right. Where you've got the smallest power or of what? Of prime factors common, of these prime factors common, of what? Prime factors common, supposed to be what? Common to both numbers. All right, so in this case, to all numbers that you're given. All right, in this case, to all these numbers that you're given, which is common. So which factors from what we listed are common? Is 2 common? No, it is not. We do not have 2 here on 375. So 2 is totally out from common. 2 is totally out. We move on to 3. 3 is common. Which one has got the smallest power? Being common, 3 is common. But which one has got the smallest power? That's 3 to the exponent of what? Of 1. 3 is same as what? 3 to the exponent of 1, which is 3 times. 5, is it common? Because it's there. But is it common? Yes, 5 is common. You can see it's there throughout. Which one is for the smallest power? 5 to the exponent of what? 5 to the exponent of 2, compared to what? 5 to the exponent of 3. So the smallest is 5 to the exponent of 2, smallest powers. All right, so this is our highest common factor, 3 times 5 squared. Thus, you can even use your calculator there, since we've got 2 marks, guys, for that. And that was going to give us what? 75 at the end. You can just use the calculator here, 3 times. All right, that's 3 times 5 to the exponent of 2, which is what? 75. So that was it on this part. You were given this one direct as it is. All right, let us consider the other part. Working with this, we have got 4 marks on this one. All right, let's see. That's 2.2. A local running club has decided to have a race. All right. So the race costs 65 Rand to enter. So that's the entrance fee. 65 what? 65 Rand. That's our entrance what? Our entrance fee. So from this, the club will keep 20% of each entrance fee. So the club is going to what? The club is going to take 20%, is going to keep 20% of the entrance fee. And the remaining funds will be given as the first, second, and third place what? Prizes. So the remaining is the one that is going what? For the prizes. So we are given in this case 1,260 people enter, and the remaining funds are split in this ratio. The remaining funds are split in this ratio for the first, second, and third place. How much money does the first place winner receive? How much? So before we consider that ratio to say, okay, they are going to use the ratio because that is what you're given in terms of splitting the funds, in terms of sharing these funds, they are shared in the ratio of 3 as to 2 as to what? As to 1. But before that, the remaining funds are the ones that were being split in the ratio. So this ratio that we are given, this sharing ratio, was for what? For the remaining funds, right? It was for the remaining funds, all right? That's remaining here, funds. What is remaining? After the club has taken what? 20%, you have kept 20% because they are going to keep what? 20%. So that is it, guys. Let us consider first the total cost, all right? So here, let us consider the total cost first. The total cost, that is, in this case, like, can we say the cost? Yeah, total cost is fine like that. Or the total amount, the total cost from this 65 Rand to enter. This is our entrance fee. So that's going to be 65 Rand per each person. How many people entered? 1,260 people entered. So you multiply by the number of people which entered. That was going to give us the total cost before the sharing process, all right? That's 1260 like this, which is going to be 81,000. So that's 81,900. All right. So that's 81,900. This is the total cost. This is the total money they received. But out of this now, so this is the total received. The club kept what? 20%. And the remaining price was the one that went. So you can calculate, it's up to you now how to calculate this. You can calculate the 20% which the club is going to take. All right. You can calculate the what? The 20% for the what? For the club. Then you subtract from the total. All right. Then you subtract that from the total. Let's say you calculate 20% of this. It was going to give us something like 16,380. Then you subtract it, the remaining price, you subtract from this total. All right. So it was going to be 81,900. This is our remaining minus what? 16,380. Then you obtain something like 65,520. This is the remaining. Or you can simply say, since we are given that the club is going to keep 20%, and the remaining price, what is remaining from 100%? If we take 20%, what is remaining from 100% total percentage, subtract 20%, you remain with what? 80%. So the remaining, which is for the price, was 80% from the percentage we do understand from what? 100%. So you can calculate that remaining, the one that was used for the what? For the prices, which is the remaining amount. It was what? From the 80%. That's 80%, which was taken for the what? For the prices. So that's 80 over 100 times what? 81,900. You were still going to obtain the same answer from those calculations that I was doing there. So that was going to give us the same answer, 80 over 100 times what? 81,900. The remaining amount is going to be what? 65,550. As we can see, that is the same answer as what we obtained before. So that's 65,520, I mean. All right. This is the one that is taken for the what? Prizes. The remaining amount is the one that we are going to share in this ratio. Remember, when you are sharing in a certain ratio, you must know the total ratio, because this is what you're going to share in a total. This is our total share for the what? For the prices. So what is our total ratio in this case? Our total ratio is what? Simply add 3 plus 2 plus 1, which is going to be what? A 6. So meaning to say, therefore, the one that was for the first, they said what? The first place winner. All right. So therefore, our first place winner is going to get how much? According to the ratio. The first place winner has got how much according to the ratio? This is the first place. This is the what? The second. This is the third. So the first place according to the ratio has got 3 parts out of the total ratio. 3 out of what? 3 out of 6 times what are they sharing? The total share, which is our remainder here for the prizes, was what? 65,520. So this is what the first prize winner, what the first prize winner is going to get. 3 over 6 times what? 65,520. So simply multiply to 3 over 6. So that was going to give us what? 32,720. All right. So that's 32,000. 760, sorry, 760. So this is it. That is the first place prize winner is going to, or that person is going to obtain this amount from what they were sharing. So remember your ratio, guys, when you are sharing the ratio. All right. So that was it. You can work with the remainder, the 80%. you calculate from that 80%. Or like I said, you use the 20%, but when you use the 20%, you must subtract from the total cost so that you remain with what? The remainder. Then the rest, you apply the same concept of calculating what? The first place winner's prize. All right. So that was it on 2.2. Let us move on to 2.3. There we are given that Peter buys, all right, let us consider this. Peter buys a smart TV on a hire purchase, loan, right? So remember, a hire purchase loan is the one that we use what? Simple interest formula for our calculations, all right? So this is the cost price, like the actual cash price that you're given, which is what? 18,800 for this amount. So this is the amount of the TV, 18,800 cash price. All right, our cash price. So here they're saying he pays 20% cash deposit and repays the remainder of the loan. He repays the remainder of the loan by equal monthly payments. So here, guys, it is the remainder which was being paid, the remainder of the loan. So what is it that he pays the remainder of what? Of the loan. So the first was a cash price, which is 18,000. Then he pays what? 20% cash deposit. So what is that cash deposit? This one is paid in what? In cash. 20% times what? 18,800, so that you can understand this question. 18,000, I mean. So 20% of this was going to give us 3,000, what? 600. 20%. Let's just try. 20 over 100 times 18,000. So this is what? 3,600. So that's 3,600. All right. So this is the cash deposit. This one. He paid. This one was actually, it's paid. It's already paid. I want you to understand this question. Here they are saying, and repays the remainder of the loan. So the remainder from the cash price, because this is what he managed to pay. So our remainder is the one that was taken as a loan to be what? Repaid. This one, it is what? The remainder, which we could have just worked again as simply applying what? 80%, just like the previous case where you were given that it is what? They kept 20%. Then you calculated the remaining one using 80%. We could have just done the same way to say the remaining, which is our loan, it is simply 80% over 100. 80 over 100 times what? 18,000. You could have just calculated this way. But if you have calculated the cash deposit separately, therefore the loan, which is our remainder, is going to be what? 18,000, the cash price of the TV minus what? Minus 3,600. So that was going to give us 14,400, all right? Let's subtract 18,000, all right, minus 3,600. That's 14,400. So we've got 14,400 like this. This is the loan which is to be repaid. He repays that by equal monthly payments. It's not about the hire purchase, about the television that was big. No, it's the loan to be repaid. This is the one to be what? To be repaid. That is what we are given there. But it is paid what? Equally monthly. All right. It is paid in those over what? A period of 2 years. So to repay this loan, it is repaid over the number of years, 2 years. All right. The interest is 16% per annum. Simple. The interest for the given loan. So you're given the interest rate, which is what? 16%. How this money is going to increase per annum per year on the full amount of the loan. Determine the monthly repayments. So the simple interest is given. This is the full amount that is going to be paid, which is your principal. The remainder, the loan, is your principal value. So that's what the loan, which in this case is what? 14,000. This is what is going to be repaid, 14,400. This is the one that you're going to need to pay up, because the first one was paid as a cash. Then the remainder now is to look for this remainder. That's the loan now, to be repaid with a simple interest. So you simply have to calculate the accumulated amount for that given loan. All right, the accumulated amount under a simple interest, that's P into 1 plus Rn, In like this, where I is simply R over 100. So on this R there, you divide by what? By 100, which is going to be 0, 0.16. All right, so that was it. The accumulated amount is going to be what? The principal is there, 14,400 into 1 plus the interest rate as a decimal, 0, 0.16 times the number of years it is to be paid in what? In 2 years. So you multiply by 2 years, then you see that, all right, this is how the loan is going to increase. It's going to increase to this value. All right, you can simplify what is inside the bracket or just simplify everything at once. 14,400 open bracket 1 plus 0, 0.16 times what? Times 2. So this is going to give us 19,000 and what? And 8. So this is 19,000 and what? And 8. What is to be repaid, accumulated? This is what he must pay. He must pay that to be repaid. It is the loan. So it is accumulated. The loan that we had initially is accumulated to this amount. So it has to be repaid now monthly for these 2 years. So what is our monthly repayment from the loan? Take note. So you're supposed to be very careful on this one. So our monthly repayment is simply going to be the accumulated amount of the loan of what? 19,000 and what? And 8 over what? The 2 years, but expressed in what? In months. So that's 2 times what? 12, which is 24 months. So I talk about what? 24 months over 24 here. So that's it. You are going to obtain the monthly repayment, which is what? Divide by 24, and that's 792. So that's 792 per month. Monthly, this is what you must pay to cover up the loan which you took of what? Of 14,400. After paying a cash price, he had to take a loan of what? 14,400. The 18,000 is not the loan, it is the cash price of the television. All right. This is what he had, but he had to use a hire purchase loan. So the loan is the remainder that you are failing to pay, because that cash deposit, you have it, you failed to pay the remaining one. So you take it as a loan to be repaid under a simple interest. All right. Then you have to repay it over what? Over 2 years, which is 24 months. So that is going to give us the monthly repayment. All right. Just like that. So any other way that you do understand, apply that one. This is just for a sake of revision. There are so many ways that you can apply. Remember, this is maths, guys, mathematics. You can apply so many ways. Question number 3, 3.1. Simplify the following without the use of a calculator. Show all calculations. 3.1.1. You are given the cube root. In this case, it is the cube root of 64, x to the exponent of 6 over 27. So the cube root of 64, the number that is going to multiply itself 3 times to give us 64, that's what? A 4. When there is an exponent like this, you take the exponent, divide to the number inside the root sign. x to the exponent of 6 over what? Over 3. The number inside the root sign is 3. So that's going to give us what? X squared. So that's 4x squared over what? The cube root of 27, we know it. That's what? A 3. The number that is going to multiply itself 3 times to give us what? 27. So this is what you're going to have at the end. All right, let us consider the second part, which is our 3.1.2, where you're given the cube root of 3 and 8 over 3 and 3 over 8 minus 5 over 2 squared, like this, right? So what is the cube root of this? We have to rewrite this as an improper fraction. Improper fraction. Multiply this, add the numerator. All right, so 8 times 3, that's a 20, what? 24. 24 plus 3, that's 27. So it's going to be the cube root of 27 over 8. All right, or you can use the calculator, shift, you press this fraction like this, all right? So you put 3 and what? And 3 over 8. This is going to give us what? 27 over 8, all right? Minus 5 over 2 to the exponent of 2. Everything is raised to the exponent of 2. So 5 to the exponent of 2, that's 25. 5 times 5, 2 to the exponent of 2, that's a 4. 2 times what? 2 times 2. Let us simplify here. The cube root of 27, we know, is 3. The cube root of 8, that's a 2, minus 25 over what? Over 4. So you are simply to subtract these two. That is 3 over 2 minus what? 25 over 4. How can we make these denominators be the same? I can easily multiply this side here to get a 4, multiply by 2 over 2. I haven't changed anything. What I simply need is to have the same denominator of what? A 4. So that's 2 times 3, which is 6. 2 times 2, that's a 4, minus 25 over 4. It will be easier for you to subtract since you've got the same base of what? A 4. You can simply subtract the numerators together. 6 minus what? 25, which is negative what? Negative 19. So that's negative 19 over what? Over 4. All right. So that is how sometimes these typical persons can actually be given as, all right. All you just need is to work out as many questions as you can. Try to do as much revision. Understanding is very, very important, guys. Understanding all the basics as per your syllabus, working with your syllabus, your annual teaching plan. I presented it for you guys. So what you simply need to do is to go through it, understand what you're given, all right? What you are expected to know, and work with that one in your term 1 and your term 2 combined together. All right, let us move on to another part, which is on 3.3. All right, 3.13. It's a division again. All right, so let us just rewrite this, multiply here, then add 1. So that was gonna be 3 times 2, that's 6 plus 1, 7 over 3. Where there's a division, introduce multiplication, then you invert the second fraction, you interchange this. So it's going to be 5 on top over what? 14. There's a division here, introduce multiplication, you invert the fraction that follows. So it's going to be what? 3 over 10. All right, that's it. Remember, under a multiplication like this, we can reduce our fractions as long it is the relationship between the numerator to the denominator. Like 3 in the denominator, 3 in the numerator can cancel. 7 in the numerator, 14 is going to give us a 2. 14 divided by 7, that's a 2. 5 in the numerator, that's 1 into 10, that's a 2 in the denominator. So we are done. The numerators can only be multiplied together. 1 times 1 times 1, which is what? Which is 1 over what? 1 times 2, which is 4. So that's 1 over 4 in simplest form, we can have it that way. All right, simple like that. Let us consider another part, 3.2. We are being given convert the decimal fraction, this one, to a percentage. Whether it is a common fraction, it's a decimal fraction, any type of a fraction, as long you're given to a percentage, simply multiply by what? 100%. So simply 0.625 times what? 100% is going to give us what? 62.5. All right, so that's 62.5. You can see 1, 2 here, or you can just use your calculator. 0.6, all right, 0.625 times what? 100% is what? 62.5 as a percentage, just like that. Then 3.3, calculate the following without the use of a calculator. Show all calculations, all right? 3.31, all right, we are given, this is just for a 1 mark, guys, all right? So what do we do here? The negative is outside of the bracket, so it's going to be there on our answer. So simply square the number. 4 to the exponent of 2, that's a 16. All right, 4 times what? 4. So the number of decimal places, you count them, 1, 2, 3, 4. So there are 4 decimal places from the first one, but we're multiplying. A squared means that it was multiplying itself to another one which has got 4 decimal places. So you add, this is for our decimal places. 4 plus 4, that's 8 decimal places. So our answer is supposed to have what? 8 decimal places. So let's count 1, 2, 3, 4, 5, 6, 7, 8. These are decimal places, the one that you obtain after what? After the comma. So the answer is going to be minus 0, this. All right, just like that. So you have to know the number of decimal places that you have. All right, after the comma, you count these ones. There are 4 of them. But since it was multiplying itself, it means it was 0.004 times 0.004 like this. Then you multiply 4 times 4, 16. Then you count 1, 2, 3, 4, 5, 6, 7, 8. That was the concept. Just like that. But there you have to consider there was a negative, so the answer is going to carry a negative. All right, so that's minus this, right? Then 3.3.2, you're given to divide these two. All right, let us simply divide 3.6 over what? 0.02. Looking into the one that has got number of decimal, the more decimal places, which is our denominator, it has got 2 decimal places. All right, these values after the comma. So simply consider multiplying by what? 100. Since we've got 2 decimal places, we must have what? 2 zeros. 100 over 100. So that's it. 3.6 times 100. That's simply moving 2 commas to the right like this. So it's going to be 360. 0.02 times 100, 2 commas, it's going to be what? A 2. 0.2, which is what? Simply a 2. So 360 divided by 2, that was going to give us 180. All right, so simple like that. Simple like that. So that is 180 at the end, and 3.4 you are given. If 2 over 5 of the production in a week is 22,000 items, all right, the production is 22,000 items, then what is 15% of the number of items, all right? 2 over 5 of the production. Do we know that? Let us just say 2 over 5 of something. Let that something be X. It is supposed to give us what? 22,000. So what is the value of X? Then we calculate 15% of that because we are asked the 15%. But what is that something? What is that number of items that we need, which is X? So how can you find X? This is 2 over 5 multiplied by the reciprocal 5 over 2 multiplied by what? 5 over 2. So this can cancel. You remain with what? X. So X is simply going to be 22,000 times what? 5 over 2, or cross multiply, then doing that, whatever way that you understand, guys. All right. So that was it. 22,000. All right, so many ways of answering. 22,000 times 5 over 2 is going to give us 55,000. So this is the value of X. 55 what? 55,000. So what is 20% of that? I mean, 15% of that. That is, then what is 15% of what? The number of items. So if our X is representing the unknown, which is number of items, so what is 15% of that? 15% of what? The number of items, the number of items. All right, items here. It's gonna be 15 over 100 times 55,000. All right, 15 over 100. Let me just use the red one here. All right, times 55,000. That is going to give us 8,250. All right, just a normal question like that you can work out with any understanding. Just use any unknown value for what is unknown, the production, then multiply by 15% to obtain that because they're asking 15% of that unknown. All right, question number 4. You are given here the part of your numeric and geometric where you are given, look into the given pattern and answer the following questions. All right, pattern 1, pattern 2, pattern 3. All right, it's like a design that is being formed. 1, 2, 3, 4, 5. So we have got 5 on the first one. 1, 2, 3, 4, 5, 6, 7, 8. The second one, it's 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, followed by 11, like that, like that. So these are the first one, like for the pattern. This is our first, this is our second, this is our third, and so on. So the question here is now on 4.1.1, how many dots will be there, all right, in the fourth and the fifth pattern, meaning to say, what is our T4, what is our T5, the following from what you're given. So you can see that analyzing our pattern, we can see that there is a constant difference between the terms 8 minus 5, there's a difference of 3. 11 minus 8, there's also a difference of 3, meaning to say we were simply adding 3 to the previous term to obtain the next one. Add a 3, you get a 8. Add 3, you get 11, and so on and so on. So the fourth term, simply add a 3. 11 plus 3, that's a 14. The fifth term, simply add a 3. 14 plus 3, that's what? 17. So those are the fourth and what? Fifth terms that you're gonna have. So how many dots? So meaning to say the fourth pattern is going to have what? 14 dots. All right. The fifth pattern is going to have what? 17 dots. That is the condition. All right. 4.1.2, determine the number of dots in the 85th pattern. Guys, this is too much. We cannot have up to the 85th. So what you can do is to have the general rule of the pattern, then find T what? T85 from what? From Tn. So it is easier that way. Simply find Tn first. So what is our Tn for this numeric? That's Bn plus what? Plus C, or An plus B. Guys, no matter the way that you understand, as long you understand what it represents, some they use Dn plus, guys. As long you understand that the part with n there is what? Your constant difference, which is 3. So that's 3n plus b if you use an plus b. So you have to find the value of b for a condition that you can use the first term. Remember, t1 equals what? Equals 5. So that's 5 is equal to 3 times our n is 1 plus b. So that's 5 is equal to 3 plus b, which is going to be a negative here. 5 minus 3, that's what? That's a 2. So meaning to say 2 is equal to what? 2 is equal to b. So that's, therefore, we can have our Tn formula from there. Our Tn is equal to what? 3n plus what? 3n plus 2. So this is what you're going to have. If this represents the general formula for the number of what? For the number of dots. What about in the 85th what? Pattern. 85th what? Pattern. The value of n is what? 85. So T85 is equal to, in place of n, you're going to put 85 there, plus what? Plus 2. So that is it. You have got the corresponding number of dots from that, which is what? 257. So you're going to have 257 dots all in all, or in what? In that 850 watt pattern. So that is the condition. You can use the general formula where you are limited, guys. Then 850, guys, you're counting 80 up to 85, listing them one by one. If you have that energy, you can do that. But this was going to be too much. The general formula was going to be easier to work with. Simply substitute into that formula. You are done. All right. Write down. All right. Write down the next two terms on question 4.2. For the number pattern that we're given, -1, 2, 4, and so on. All right. So this is our first, our second, our third. Do we have a constant difference or a constant ratio here? If we check, if we subtract this, it was going to be 2 minus -1, which is a 3. Then if we subtract it, it was going to be -4 minus 2, which is -6. So the constant difference does not work. So let's move on to the constant ratio. All right. If the constant difference does not work, you move on to the constant ratio. Term 2 over term 1, T2 over T1, that's 2 over what? 2 over -1, which is -2. T3, you move on. T3 over what? Over T2. It is going to give us -4 over what? Over 2, which is -2. As we can see, they are the same. So in this case of our number pattern, it is a geometric, all right, where we have got what? The constant ratio. So it means the next terms were simply obtained by multiplying by -2. From the previous term, you multiply by -2. -1 times -2, you get this one. All right. So this one times -2, you get this one. So the same thing, -4, you multiply -2. -4 times -2, that's a positive what? A positive 8. The next one again, multiplied by -2. 8 times -2, that's what? A -16. So those were the next two terms, 8 and what? 8 and what? -16. All right. From this understanding of what we are given, 2 marks for that. Use the rule to determine the missing input and output values for 2 marks. All right, our 4.3. So we have got this rule that we are given. All right, remember these are the input values and these are your output values. So let's start with A is on the what? On the output. It represents the Y value. All right, the output values, these are Y values. Input, these are what? X values. So you're given this rule, y is equal to -1 over 4x plus what? Plus 2. So simply substitute what you're given. We are given, for us to calculate A, it's our output. It represents the Y value. When the input is what? Is X. Our X is what? 8. So what is the value of Y when our X is what? When our X on the input is 8. You substitute what you're given into the equation. So that is going to give us the value of what? The value of A. All right, so that was it. -1 over 4. All right, -1 over 4 times what? Times 8 plus 2. This is going to give us a 0. So the value of Y that corresponds when X is 8 is what? Is a 0 here. So that's our A. All right, so A is equal to 0. Just like that, you move on to the second part, which is finding B. B is on the input. It represents what? The X value. Those are X values. So we need the value of B given the output. The output is given as what? As 3, which is what? The Y value. You have the Y value this time. What you do not have is what? The X value on the input, which represents B. So you form an equation from that. You have the Y value, you do not have the X value. You formed an equation. Solve for X. All right, we can take the 2 to the other side as this is a linear equation. Take the 2 to the other side or simply subtract 2 both sides. So you're going to get negative 1 over 4x equal to 3 minus 2, that's a 1. So to find the value of x, we can divide by minus 1 over 4. You can cross multiply. It is up to you. 1 times minus x is equal to 1 times 4. That's a 4. So divide by negative 1 by negative 1. X is equal to what? X is equal to negative 4. Where x is the input, that's the value of b that we substituted at the input here. So that's b is what? A positive, sorry, a negative what? A negative 4. So b is equal to what? Negative 4, the value of x. So that's it on that relationship that you're given between x and y, that rule. All right, let us consider this one, 4.4. Consider the table below. 4.4.1, determine the rule in the form y is equal to. All right, that shows the relationship between x and y. All right, so you have to be careful when you're given this type of a question, guys. All right, considering that these are mixed values on the input and output, and as they are mixed, do we have consecutive values? A rule is obtained from what? Consecutive values, the ones that are following each other. So if we check, the first one is minus 4 on the input, which is the x, followed by minus 2. This here does not make sense. If the next one is negative 1, so we must have consecutive following each other. All right. So if we've got minus 4, it's supposed to be minus 3, minus 2, minus 1, 0, 1, 2, 3, like that, consecutive. But if we check what is happening here between these two, or here between these, and it's not consecutive. The consecutive part here is from minus 2, minus 1, 0. They are consecutive. The next one is no longer consecutive. We move on to what? To 3. From 0 to 3. This is not what? Consecutive. From 3 to 5, from 5 to 8, these are not consecutive. So from the consecutive input values, you can find the relationship from these ones that are what? Consecutive, to say when you are given that, you can tell from the output values, because output values will also be what? Be consecutive. If the input values are consecutive, output values are also consecutive. So therefore, you were forming, actually in this case, you are going to form a pattern from these output values. Now, what is the difference between these? Minus 9 minus 13, minus 9 minus 13, like this. All right. This was going to give us a 4. Minus 5 minus 9 was going to also give us a difference of 4. That is to show you that these are consecutive, same difference. So that's a linear, which you're supposed to write in the form Tn is equal to An plus B. But since it is in the written in the form y is equal to, so that's in the form of y is equal to what? Ax plus B, if you want to have it that way, where A is the same as what you have, or you can use mx plus c, whatever way that you understand, where a is that difference of what? Of 4. So you're saying y is equal to 4x plus what? Plus b. So to find the value of b, if you use it as y is equal to mx plus c, to find the value of c, you can substitute any now of these what? Of these points, anyone that you want, anyone. When x is equal to 0, y is equal to minus 5. I'm going to use that. X is equal to 0, y is minus 5. You use any one of your choice. So where x is a 0, y is what? Negative 5. So it follows that b is equal to what? B is equal to negative 5. So therefore, y is equal to 4x plus b. Our b is what? Our b is negative 5. So that is what you are going to have at the end as the rule, all right? From consecutive terms, That's how you must work it this way. You must work it from what? Consecutive terms, of which there are so many ways. You can actually do it finding equation of a straight line where you use the gradient concept. You can take the points, all right? Any 2 points, -1 and -9 and 0 minus 15, you find the equation of a straight line from the gradient concept, then you're still going to obtain the same answer, right? So that is it. That is it, just like that. So y is equal to what? 4x minus 5. Then on 4.42, use the rule that you obtained here on 4.41 to determine the values of P and Q. All right. From this rule, what is P representing? P is the value of Y. This is the output. When the input value is what? Is X. Our X is what? 8. So Y is equal to what? When X is what? When X is 8. That is the question. So that's 32 minus 5. And that is going to give us what? A 27. So P is equal to 27. What about Q? All right, we do the same thing on Q. Q represents the input value, the value of X. We do not have the value of X given the value of Y. Y is 39. So we have the value of Y is 39. 39 is equal to what? 4x minus what? 4x minus 5. You solve for X. By solving for X, you are finding the value of Q, as Q represents the X value. All right. How do I get rid of the -5? Simply add 5 both sides. So that's it. 4x is equal to what? That's going to be 44. All right, that's 44. If we add 39 plus 5, then divide by 4 to find the value of what? The value of x from there. So x is going to be what? 4 into 44, that's 11. So the value of x is our q. So q is going to be what? Q is going to be 11 from this understanding of our information. All right, from this understanding, you simply work with the rule, the equation that you have formed between x and y. All right, let us consider another part, which is question number 5. All right, 5.1. Calculate the following without the use of a calculator. Show all the calculations. All right, show all calculations on 5.1.1. All right, let us consider this for 3 marks. So what can we do? We have to also consider our board mass as well. All right, so what we can simply do here is -6 plus the square root of 4 times 4 minus 9 minus 5. So we can consider the brackets as we are considering the board mass brackets. There is a bracket here. There is also a bracket here. So you have to consider being multiplied by what is outside. It's also part of the bracket. We also have to get rid of that bracket. All right. But as we consider those brackets, guys, they are simplification like these square roots. They follow those brackets. Again, you can also simplify that and the same place parts just like a bracket from what we are given can be simplified. All right, so sorry for that. Sorry for that. I just wanted to change this thing. All right, so this is part of the brackets as well. So you can see that it's gonna be -6 plus the square root of 4. We know that. Simplify that, guys. All right, so this is gonna give us a 2 times simplifying the bracket here. We are going to obtain 4 minus 9, which is what? -5. Then here there's a bracket, all right? Negative, negative is going to give us what? A +5, like that. All right? Don't be tempted to add these two since we have got what? A product, board mass. After that, we've got a multiplication to be what? Considered. These two, they are multiplying each other. 2, +2, and what? -5. So don't be tempted to add those two. These two, they are what? Multiplying each other according to our board mass concept. So it's going to be -6, all right? 2 times -5. If you multiply 2 and -5, you get a -10 plus what? Plus this 5 that is remaining here. So we can simplify, all right? Addition, subtraction can be done at the same time. You can just evaluate this one straightforward. -6 minus 10, that's -16 plus 5. So 5 minus 16, we are now going back 16 steps going back. So it's going to be -11. all right? Or simply subtract 16 minus 5, you get 11. Then you take the sign of the bigger number on your answer. So that was it. You are done, all right? You are done just like that. Then let us consider 5 point, all right, 5.1.2. There you can simply just evaluate minus 3 squared. It is the 3 which is being raised to the power of 2. So it remains with what? A negative. So that's negative 3 squared. That is what? 9 times the square root. You can simplify what is inside the square root. That's simply 9 plus 16, which is the square root of what? 25. So this is the square root of 25. All right. Plus, you can simplify 2 to the exponent of what? Of 3, which is 8. So that's minus 3 times 8 over what? Minus 2 minus 6. That's simply what? Minus 8. You're going back 6 times, or just add these two. 2 plus 6, that's what? 8. Then you take the common sign on your answer. When the signs are the same, you use that common sign on your answer. All right, this is where we are. We can simplify. We know the square root of 25 is what? Is 5. All right, then here we're going to multiply negative 3 times 8. That's negative 24 over what? Over a negative 8. So negative cancels. And 24 divided by 8 is going to give us what? A 3. So that's going to be positive 3 here at the end. All right. So let's consider our board mass multiplication before addition. So you are supposed to multiply these two first. So negative 9 times 5, that's negative what? Negative to a positive, that's negative 45 plus what? Plus 3. So that's it. The signs are different. So subtract the smaller number from the bigger number. That is going to give us 42. Then use the sign of the bigger number on your answer. So the answer was going to be negative 42 at the end. All right, so that is it. Some of these part calculations, you can use calculators, guys, on the part calculation like this one. Multiplication of these two, subtraction of these, guys, you can just even use a calculator. No one is going to know that you've used a calculator for that. Simplify this. All right, let's consider what we have. There we simply have to consider the idea of what? Working with the same basis on 5.2.1. The base of A and the base of A, you're multiplying, simply add the exponents. 1 plus what? 1 plus 2. The base of B, this is B to the exponent of 1. This is B to the exponent of 3. Add the exponents. So that's A to the exponent of what? Of 3. B to the exponent of what? Of 4. Just like that, all right? So 5.2.2, you're given to simplify again this. Consider again the laws of exponents. Where you have got the laws of exponents, guys, use that 3x squared times 4xy to the exponent of 7 over what? All right, so this is over 2x squared y like this times 6x times y like this. All right, so that is the condition of our question that we are given. So under a product, you can simply multiply direct, the way that you understand the numbers, 3 times 4, that's a 12. But where you have got the same base now, the base of x and the base of x, you have to consider that you're under a multiplication. So you have to add what? You have to add the exponents. From our laws of exponents, you add the exponents, we have got the same base. So it's going to be x to the exponent of what? Of 3. All right. Y is just going to remain as it is to the exponent of 7. Over what? The denominator, the same thing. You can just multiply the numbers. Y there, same, there's a 1. So that's 2 times 6 times 1. 2 times 6, that's 12 times 1, which is 12. So that was going to give us 12 in this case. Considering x, the base of x, this is to the exponent of 1. So you add the exponents as you're multiplying same base. X to the exponent of 2 plus what? Plus 1. So that's x to the exponent of what? Of 3. Then y, there is y to the exponent of 1. This is y to the exponent of 1. So you add the powers, y to the power of 1 plus 1, which is what? Y squared. So y is raised to the exponent of 2. from what we are given. All right, so let us consider our division. Division, same basis. Remember, you subtract the exponents. So the numbers, just divide them direct. 12 over 12, that's going to give us a 1. All right, so you can see that x is the same. This is x cubed, x cubed. So these two can cancel. So you're left with y in this case, the same base, subtract the exponents, y to the exponent of 7 minus what? Minus 2. So that is going to give us y to the exponent of 7 minus 2, which is what? Which is 5. So this is y to the exponent of what? Of 5. That is it. Just like that. All right, just like that. So that's our revision, guys. Do revise as many questions as you can. All right, let us consider 5.2.3. There is, all right, let's see what we have here. Negative 2x squared y squared to the exponent of 3. All right, sorry, this is affected with the denominator as well, xy to the exponent of 3, like this, all right, plus 2xy to the exponent of 0. All right, so many ways that we can simplify this. We can start by what is inside the bracket, just considering that same concept, subtracting the exponents where we've got the same base. So it was going to be negative 2x to the exponent of 2 minus 1, which is simply x. All right, y the same, 2 minus 1, that's simply y there, to the exponent of what? To the exponent of 3. Plus, there we have got 2xy to the exponent of 0. Any number raised to the exponent of 0 gives us what? A 1. So the whole bracket is raised to the exponent of 0. So the answer is going to be a 1. All right, so there we can simplify. Each term inside the bracket is raised to the exponent of 3. Negative is raised to the exponent of 3. When a negative is raised to the exponent of an odd, it remains as a negative. It only changes when raised to an exponent of what? Of an even power, it's going to be a positive. So in this case, the negative is going to remain. All right, so that is a consideration of the sign. The negative is going to remain. 2 to the exponent of 3 is what? 8. 2 times 2 times 2. X to the exponent of 3. Y to the exponent of what? Of 3. Every term, everything inside the bracket is raised to the exponent of 3. So do not forget to add the 1 that we obtained from that one raised to the exponent of 0. Can this be simplified? No. These are unlike terms. You cannot combine them. So you leave your answer like this, all right? Just like that. So that is how you can play around with these typical questions. Just try to do as much revision as you can. All right, 5.3, consider the expression and answer the following questions from there. Right, this is our expression, negative this, x, and so on and so on. 5.31, how many terms are there in the expression? 1, 2, 3, 4, 5. There are 5 what? 5 terms. 5.3.2, what is the coefficient of the term in x? The term in x. This is the term in what? In x. X here. This is the term in x. So what is the coefficient? The number that is multiplying x here is what? Negative 1 over 3. So the coefficient is the one that we need. The coefficient is what? Negative 1 over 3. All right? Just like that. Then let's consider 5.4, simplify this expression. All right, there is just about the like terms, all right? Just considering the like terms, the terms in x. So there is 4x, there is x. That is the only part that we have with what? With x. So simply add 4x plus 1x. That is going to give us what? 5x. Then we consider the terms with y there. We've got minus 8y minus y plus what? Plus 3y in this case. All right, so this is going to be negative 1. So that's the part of y. It's negative 8 minus 1 plus what? Plus 3. Negative 9 plus 3, that's what? Negative 6. Or you can just use a calculator there. So that's negative 6y. Then z is the one that is remaining. There's a z, a z here. All right, so this is 1z. So if you add 1 plus 2, that was going to give us 3z. And this is what? Minus 3z. So if we subtract this, is going to give us what? A 0. So the part of z, guys, was going to be 0z, which is what? Nothing there to consider. So that is what you're going to have at the end. All right, just like that. Then considering 5.5, you are given these statements actually. A plus B is equal to 16, B plus C is 4, A plus C is 10. Determine the value of this, all right? A plus B plus C to the exponent of 3. How can we obtain A plus B plus C? Simply add them. This is A plus B, the first one. A plus B gives us what? 16. Then if you check the next one, it has B and C. So take that one. B plus C is equal to what? 14. The following one, it has A and C. So add again. A plus C gives us what? A 10. Add them together. Let's see what are we going to have. So we add the terms in what? In A. All right? Together, that's A plus A, which is what? Which is 2A. All right. So that is going to give us, sorry for that. This is going to give us 2A. The same thing with the B. This is B, this is B. So B plus B is going to give us what? 2B. The C and the C, add them together. That's 2C. All right. And this is equal to add these numbers together. So if you're going to add those 16 plus 14 plus 10, that was going to give us what? 40. So this is what you have. 2A plus 2B plus 2C is equal to what? Is equal to 40. So what is it that we are looking for? Remember, we are looking for A plus B plus C. But there it is 2A, 2B, 2C. Are we seeing that the 2 is common throughout? So you can easily factor out the 2. Then you remain with A plus B plus what? Plus C, which is equal to 40. So if this is equal to 40, what about A plus B plus C? This bracket, simply divide by what? By 2. As you have got a product here, divide by what? Divide by 2. So you have an expression, you have the equivalent, I mean, for A plus B plus C, numerically, 40 divided by 2 is what? A 20. So you have the numerical value for what? A plus B plus C. So the question is, if you take that and raise it to the exponent of 3, what are you going to have? If A plus B plus C represents 20, substitute it here, all right? So that's 20 to the exponent of what? Of 3. So that is the idea there. 20 to the exponent of 3 gives us what? So simply use your calculator there. 20 to the exponent of 3, that is 8,000. So that is what the question was all about. This is the numerical value of what you are being given, A plus B plus C to the exponent of 3. So that was it, having 3 marks and a total of 18 marks on question number 5. And that was actually the last part of our question. So let us do revise as much questions as we can as we are preparing ourselves for the exams ahead of time. Make sure that you do understand all the basics from your term 1. So that is it, guys. Till we meet again.